9.5, solving quadratic equations by taking square roots. Today's lesson is pretty simple, but it does not always work. It only works when we have one side of our equation being squared equal to, and then a constant on the other side. So take a quick note, y'all, just really quickly, and notice that ax plus bx plus c is our standard form. In order to use this method, you cannot have a b value, to use this method. Okay, so just kind of getting that out of the way. One more time, it only works when we have a number being squared equal to a constant. In other words, we don't have a term with just x. We don't have b. All right, let's go ahead and let's take a quick look. We have x squared equals 36. And we know that we need to get to x equals, right? So basically, how do I get rid of this something right here being squared? Now, you probably actually already know the answer. I mean, honestly, what squared is 36? Yeah, you're thinking of the number. You already know. But just take a quick second. How do we actually mathematically get rid of this something being squared? We square root, right? You do the opposite. If I square something, the opposite of squaring something would be to square root that something. So I'm going to go ahead and square root x squared, and that's how I get x, right? Think about how that works. It's like square rooting x times x. Well, both of these would leave, and nothing is left inside, right? That's why we just are getting x. So the square root of x squared is x. Now, if I square root the left side of the equation, gotta be fair, and I got to square root the right side. And the square root of 36, we all know, and if you don't know, use your calculator, right? Square root of 36 is just 6, right? Perfect. But that's not all. What else can I square and get 36? What about if I square negative 6, right? What's negative 6 times negative 6? Isn't that also 36? So what we do here, because there are actually two numbers that work, is I use what's called a plus or minus sign. All right, I'm going to make a little note. This is called a plus or minus sign. All right, and what this means is that x equals positive 6 and, excuse the bell here, x equals negative 6. All right. And just if you want to see this graphed, we would just graph x squared, and then we would move the 36 over to the left side, which means it would become a minus 36. Hopefully you know that from Monday's lesson. And look at my graph. Yeah, I see a negative 6 and a positive 6. I got a 2 zeros, so that's why you have to have the plus or minus. If you don't have the plus or minus, you only have one of the answers, which means that you are halfway right, but also halfway wrong, which we don't want. All right, so the moral of the story here is square root both sides of the equation. Don't forget the plus or minus sign. Problem 2. All right, well, this looks similar to problem 1, except we got this 3 right here. Now, we do have to get rid of the 3. You cannot do the whole square root thing until you just have x squared, or just something being squared. So let's get rid of the 3. Since it's multiplying x, we know that we can divide to get rid of it. Got to do it to both sides of the equation. So now I have x squared equals 25. Now, I know you probably already know the answer. What squared is 25? But mathematically, here's what this looks like. We're going to square root the left side, so we just get x equals. But then we got to square root the right side, and the square root of 25 we know is 5. Don't forget your plus or minus sign, because either of those numbers could square to get you 25. All right, so plus or minus 5. Let's take a look at problem number 3. We have x squared minus 20, so in this case, it's the minus 20 that needs to go away. So to do that, you do the opposite of whatever it's doing to x, which in this case is we're going to add 20 to both sides. So I've got x squared equals 80 plus 20 is 100. Now I can do my square rooting, square root both sides, and I have x equals, what's the square root of 100? Hopefully you know, but again, if you don't, remember second, and then your x squared button, type it in there, it'll give you that answer. Square root of 100 is just 10. Don't forget though, positive or negative 10. Your calculator doesn't tell that to you. That's something you have to remember. And again, it all comes back to the fact that what squared equals 100? 10 times 10, or also possibly negative 10 times negative 10. Problem 4. Okay, in problem 4, we have this 3 we need to get rid of and also the 43 we need to get rid of. Does it matter which of those I get rid of first? Absolutely, it does. Remember, whatever's touching your variable, save that for last, which means that the first thing I'm going to do is get rid of this 43. And I'm going to subtract it, right, do the opposite, which means that I've got 3x squared equals 147. Now, just like the previous problem, I think number 2, we're going to divide out the 3 to get rid of it, which means now I've got x squared is equal to 49. All right, let's square root both sides of our equation to get me x equals, don't forget plus minus, and let's see, what is the square root of 49? Again, you probably already know, but if not, calculator helps us. Square root of 49 is 7. All right, that is my final answer there. Now you'll notice that all my numbers are coming out beautiful, which is great. That is not always the case, but if you're getting an answer that's not really very beautiful, then probably the quadratic formula is a good one to use, which we're going to learn tomorrow, or just simplify radicals, which again is in one of my older videos. Problem 5, the area of a square, so let's draw a square, right? I love drawing pictures. You guys probably know that by now. All right, area of a square, that's a crappy square. Area of a square is 144 inches. It says the length of one side is 3x. What is the value of x? All right, well, the area is 144, so let's have something equals 144. And then let's remember that it's a square. So I know the other sides of this box. I know they're 3x. I also know area, right? We know area is equal to length times width. Or you can do side times sides because it's a square, or base times height, whatever. That's my area. And now let's go ahead and let's write this out. So 3x times 3x. Well, then we get 9x squared equals 144. And now this becomes a problem like we've already done. We're just going to divide out that 9, which gives me x squared is equal to 16. And then we're going to square root both sides. And I get x is equal to positive or negative 4. Now hang on a second. Why am I telling you no negative lengths? Right? Think about it. It's actually a real problem that we're talking about. If I did 3 times negative 4, I'd get negative 12 inches. Can I have negative 12 inches for the side of my box? No, that doesn't make sense. So we're just going to say positive 4 inches. That is the value of x. Not negative. Don't put the plus or minus sign, just plain old 4 inches, okay? We only worry about negatives or positives when we're talking about a real life situation, right? That's when we question the reasonableness of our answer, is if it's really applying to something in real life. I mean, you can always question the reasonableness of your answer. I shouldn't say that's only when we do it, but if you have a real life situation, remember to think critically about what makes sense for the situation, all right? Again, do not forget your plus minus signs. And remember, your calculator can do square roots for you. This is a great method when you just have the x squared and the constants. All right, good luck.